Hi everyone, I am Rajit, student in Department of Electronics and Communication, VVIT number. Today we are going to discuss about what is combination logic circuits and half adder. Okay, let's start with introduction. All digital systems like computer, mobile phone, calculator are built by using these logic circuits. What is logic circuit? Logic circuits are nothing but the combination of logic gates. These logic circuits are take inputs like zeros and ones and produce output current corresponding to the system we use. Okay. In digital electronics, there are two types of logic circuits: sequential logic circuits and combination logic circuits. In this seminar, we discuss about combination logic circuits in detail. Okay, let us see what are the combination logic circuits. Combination logic circuits are the circuits in which the output of the system depends on the present inputs, does not on previous or past outputs. Okay, it does not have any memory element from the output to input. So the output of the system is depends on only present inputs. Okay, let's see. Circuits in which output depends on present inputs. No feedback or memory element present in this. Examples of combination logic circuits are adders, subtractors, multiplexers, decoders, etc. Adders and subtractors are used to perform binary addition and subtraction. Multiplexers are used to select data, and code converters. Code converters are used to convert code from binary to gray, XS3 like that. Okay, let us see the basic block diagram of the combinational logic circuits. It has AND inputs and AND outputs. The inputs of the combinational logic circuits are called as excitations and output is called as responses. Okay, now we discuss about sequential logic circuits. In previous, we discussed about combinational logic circuits, which does not have memory element or feedback element. Okay, by adding memory or feedback element to these combinational circuits, we can the sequential logic circuits are obtained. Okay, so that the output of the sequential logic circuit depends on the present input and past output. Okay, here the memory elements and feedback elements are latches and flip-flops are used. Okay, these are used in counters, shift registers, etc. Okay, in storage devices also sequential logic circuits are used, and also it is used in timing control applications of digital system. As we see the block diagram of the sequential logic circuit, it has external inputs and an input from the previously stored data. Okay, and outputs. Okay, the output, the one of the output is go to the memory element. From this memory element is goes to the input. So this gives the feedback connection from output to input. Okay, so from this block diagram we can conclude that the output of these sequential logic circuits depends upon the present inputs and as well as the previous output. Thank Okay, let's see the designing steps for the combination logic circuits. These steps are common for all combination logic circuit designing. Let's see. Defining the problem. In this step, we define the problem for what we are designing for our combination logic circuit. Later, next identify the inputs and outputs of the combination logic circuit. Based on the inputs and output, consider the truth table. From this truth table, we can obtain the Boolean expression, which we can further simplify by using K-math, algebra, or tabular method. Based on the simplified equation, draw the logic circuit diagram and verify the output of the circuit operation. Okay, in this we are simplifying the obtained Boolean expression in order to reduce the number of gates required for the construction or designing of the combinational logic circuit. Okay, let's discuss about adders. Adders are used to perform binary additions. Okay, these are very crucial in performing arithmetic operations in microcontrollers, microprocessors, etc. Okay, there are two types of adders: half adder and full adder. Half adder has two single-bit binary numbers, and full adder has three-bit numbers, including carry. Okay, let's discuss about half adder. Half adder is a combination logic circuit that has two single bits. It is used to perform arithmetic operation like addition. Okay, it has two inputs A and B and two outputs sum and carry. It is a simple type of adder which is used for designing of complex adders like full ladder, parallel ladder, etc. Okay, let's have a look on the basic block diagram of this half adder circuit. Half adder. Okay, it has two inputs A and B and two outputs carry out and sum. Okay, from this we have obtained the truth table and we further discuss about the designing steps of this half adder. Next, here we can see the truth table of the half adder. It has two inputs. For two inputs, the number of possible combinations are 4. 0, 0, 0, 1, 1, 0, or not. Okay, and outputs carry out and sum. For 0, 0 input combination, we have carry 0, sum 0. 1, 0 combination, we have carry 0 and sum 1. For 0, 1 combination, we have carry 0 and sum 1. And finally, we have for combination 1, 1, we have carry 1 and sum 0. From this two table, we can derive the logic expression and further simplify for the construction of half adder. Okay, from the above truth table, we can conclude that the sum expression as a b bar and plus b a bar b. Okay, the as we see this is the standard form of the XOR operation, right? So we can simply represent this as a XOR b. Similarly, from the truth table, we conclude that carry is expressed as and. Okay, C equal to A and B. We can simply represent the carry as with AND gate and sum with XOR gate. Okay, designing of half-adder circuit diagram. As we seen above from the logic expression, the sum is obtained by using XOR gate and carry is obtained by using AND gate. So by using these two logic gates, we can simply implement the half-adder circuit. Okay, giving input A and B to the XOR and input A and B to the XOR gate gives the circuit of the half adder. Okay, now we can see the implementation of half adder circuit using different logic gates. First, we discuss about implementation using basic gates like AND, OR, NOT gate, etc. From the truth table, the obtained expression is A bar B plus A B bar. Okay, which is nothing but XOR operation. So XOR can be implemented by using the basic gates AND, or NOT. As we seen this circuit diagram, which creates the XOR gate. This part. This part creates an XOR gate. And as the carry is implemented by using AND gate, we simply use AND gate. This is how we implement the half adder circuit using these basic gates. Okay, now we discuss about how we implement half adder using NAND gate. For the implementation of half adder using NAND gate, we are using 4 NAND gates. Okay, let us consider this as 1, 2, 3, and 4. Okay, at the first NAND gate, the inputs are A and B. We get output as A, B bar. Okay, for second and third input, third logic gate, we give input as one input as A, B bar, and for second, we give another input as A, and for third logic gate, we give another input as B. Okay, the output of second gate is A into AB bar whole bar, and the output of third gate is B into A bar B, A B whole bar. Okay, these two inputs are given to the fourth NAND gate, which gives the output as A into AB bar whole bar into B into AB whole bar and gives whole bar to all. Okay, if we simplify these expression, we get XOR operation like A XOR B. This is how we implement half adder using NAND gate. Okay, let's discuss about applications of half adder circuit. This is used in binary addition in digital calculators. Okay, without this half adder circuit and adders, A calculator does not add two numbers. Okay. This is also used in arithmetical logical units in microprocessors, microcontrollers, etc. Okay. In microcontrollers and microprocessors, there is an ALU which is used to calculate the physical address of the locations in which the data is stored. So in that half adder circuits are used. Half adders or full adders like. And similarly, all the signals now we are using are digital. Okay, these softwares are used for processing of digital signals, and these are half adders are also used for designing of complex adders like parallel adder, full adders, etc. Okay, that's all about designing and operation of half adder circuit. Now we discuss about limitations of half adder circuit. Okay, as we discussed above, we have only two inputs in half adder. It does not add carry from the previous stage. So this is becomes one of the main disadvantage of the half adder. And also it only performs two single bit numbers only. So for multi-bit operations, it does not support it. So we go to full adder for multi-bit operations. Okay. Okay, let's conclude what we discussed in this. First, combination logic circuits. Okay, combination logic circuits are the circuits in which output depends on present inputs. It does not have memory element or feedback to output. Okay, this gives output immediately after entering the inputs. For example, in real life example, we can say that vending machine. If we press the button, the output comes immediately. It does not depend on previous what you have taken. Okay, this is one of the best real life example for the combinational circuits. And later we discuss about half adder. It is a basic type of adder which performs two single bit binary addition. It has two inputs, A sum, A and B, and two outputs, sum and carry. These half-adder circuits are very crucial for and essential for designing of arithmetic complex circuits like A, arithmetical logical unit, and full adders, etc. Okay, this is all about combinational logic circuits and half-adder. Thank you.